Okay, in this section, we're going to learn the derivatives of inverses. Before we start, the reason why you need to know how to find the derivative of inverses, if I can find my marker, there it is. Remember what an inverse is, just a reminder what an inverse is. Y equals 2x plus 3. Inverse is when you interchange the x's and the y's and you solve for y, if you remember. This one and this one are said to be inverses. So this little -1 stands for inverse. It does not stand for derivative. So the derivative of the sine inverse is 1 over the square root of 1 minus u squared. But don't forget to find the derivative of u squared. The cosine is very similar to it, except the only difference between sine and cosine is the negative sign. So sine and cosine are very similar. Tangent and cotangent are very similar. So tangent inverse and cotangent inverse are very similar, except the cotangent has a negative sign. So the c's, let's start with the c's, always have a negative sign. And then the derivative of secant and cosecant, again, the c's have a negative, they're exactly the same. This is very difficult because the simplifying part is very difficult. So let's try some of these now. And yes, you kind of have to memorize these formulas, but there's really only 3 of them. I'll bring them back again. There's really 3 of them because this one and this one are the same other than the plus or minus. So you're really only memorizing 3 of them. These 2 are the same except the plus or minus. And these 2 are really the same. So you're really only memorizing 3 of them. Okay, next page. Find the derivative of the inverse of the secant. So I'm going to write the formula down. Y prime for inverse. Y prime for before we do, let's do one extra one. Let's start with an easier one. Let's start with find the derivative of the sine inverse of 2x. So let's go back to the first page and let's look at sine inverse. It's going to be this one, so I'm going to copy this one down. 1 over the square root of 1 minus u squared du dx. Really important part right here. So you're going to put 1 over the square root of 1 minus, and this stands for u. So 2x times 2x is 4x squared. But then you also have to take the derivative of u, and the derivative of 2x is 2. And that's why there's a 2 up there. Okay, now let's do a little bit harder one here. The derivative of secant is 1 over the absolute value of u times the square root of u squared minus 1 du dx. This stands for u. So you're just going to do y prime is equal to 1 over u. U is 5x to the 4th, so you're going to put that in your absolute value. Square root of 5x to the 4th squared minus 1 times the derivative of u, and the derivative of u is 20x to the 3rd. Okay, that's not too difficult to plug it into there, but then how do you simplify it? 5 can go into 20 4 times, and x to the 3rd and x to the 4th ends up just being an x, and you need to have the absolute value because this ends up being x to the 1st, so you need the absolute value, and then down here it's going to be 25x to the 8th minus 1. Final answer. Okay, the next one. Particle moves and the position is x of t is equal to tangent inverse of the square root of t. Find the velocity at t is equal to 16. Okay, so you're going to come down here and you're going to look at the derivative. Remember, the derivative is 1 plus u squared du dx. That's for the inverse tangent. So you're going to come over here and you're going to put 1 over 1 plus t, because t is your u value, and if you take the square root of t times the square root of t, you're going to get t. But then you also have to take the derivative of t. And the derivative of t is 1/2 t to the negative 1/2, which simplifies to 1 over 2. It's 1 over 2. You're going to have the square root of t, and then you're also going to have 1 plus t down below. But then they want you to find the velocity or the derivative at t is equal to 16, so you're going to replace 2, the t, 16, with 1 plus 16. And this is going to be 1 over 2 times 4 times 17, which ends up being 1 over 136. Okay, let's do another one. Find the derivative of y equals the cosecant of a negative 1 inverse, that means inverse, of x over 2. So you got to watch really carefully. So first of all, I'm going to write the formula down for cosecant. Cosecant is c, so it needs to have a negative 1, absolute value of u, square root of u squared minus 1 du dx. Okay, that's the derivative. So y prime is equal to negative 1 over the absolute, this remember is u, so you're going to put x divided by 2. And then inside of here, you're going to go x over 2 squared minus 1. Okay, now comes the algebra part. You have to know how to simplify this. I'm just going to write it as x over 2. This is going to end up being x squared over 4 minus 1. Okay, but you still have to simplify this. This is going to be a negative 1, x over 2. Common denominator in here is 4, so it's going to be x squared over 4 minus 4 over 4, which looks like this. Negative 1 over x over 2, square root of x squared minus 4 over 4. Y prime equals negative 1 over absolute value of x over 2. I can break this up into x squared minus 4 all over the square root of 4. So y prime is equal to negative 1 over x over 2. Notice I've done nothing to this and nothing to this. I'm going to leave this as the square root of x squared minus 4, but the square root of 4 is 2. Then y prime, this it's going to end up being, this can flip up, so this is going to be 2 over negative 2. This can flip up and you're going to have an x, and then you're going to have the square root of x minus 4 all over 2. And then you're going to have y prime equals a negative 2 over 1 times x, the square root of x minus 4 over 2. But you need to flip this. I didn't flip it, sorry. Which y prime is equal to a negative 4 over the absolute value of x, square root of x squared minus 4, but I forgot to do one thing. I forgot to take the derivative of, I still have to take the derivative of du dx. I haven't done that. I have to go back and do that. Well, if you think of x over 2, that's why I wanted to wait and do this anyway. X over 2 is the same thing as a half of an x. The derivative of 3x is 3. The derivative of 2x is 2. So the derivative of a half of an x is just a half. So I need to have a half right here. So my final answer is a negative 2 over the absolute value of x times the square root of x squared minus 4. This type of problem is going to be on the AP test. And kids that can do this type of a problem will get a 5 on the AP test. That's how difficult the AP test is going to look like. Okay, we only have 2 problems left. Let's do the cotangent. The formula for cotangent needs to be a negative because of the cotangent du dx. A lot of people forget that, so don't forget that. So you're going to put a negative 1 over 1 plus. If you square this, which is your u, you're going to just get t minus 1 down there. But then you have to take the derivative of that, and the derivative of that is 1/2. Leave the inside alone, make that a negative 1/2, and the derivative of t minus 1 is 1. So now we have to simplify this. These two cancel out, so we're left with negative 1 over t times, this is going to end up being 1/2 square root of t minus 1, which simplifies to a negative 1 over 2t root t minus 1. That's the derivative. And the last problem. F of x equals the cosine of x plus 3x. They want you to find f of 0, f prime of 0, f inverse of 1, f inverse slope at 1. See the difference between these? So f of 0, all you do for A is just plug 0 in for x in the original problem. The cosine of 0 is 1, and 1 plus 0 equals 1. So f of 0 equals 1, and I'm going to write that over here. F of 0 equals 1. And now I'm trying to find what's the derivative at 0. The derivative of 0, the cosine is a negative sine of x plus 3. That's the derivative. But now you have to put 0 in. The sine at 0 is 0, and you get 3. So f prime of 0 is equal to 3. Okay, now comes the next part. I want to go all the way back to the first page. Remember how we found the inverses? If x is 0, y is 3. That means on its inverse, you just interchange the x's and the y. That means on this one, when x is 3, y is 0. Do you see that we interchange the x's and the y's? It's the same concept with this. What's the inverse of 1? So this is the B part. Well, if f of 0 equals 1, then f inverse of 1 must equal 0 because we interchanged the x's and the y's. And then what's the inverse slope at 1? It's not the it's just they're reciprocals of each other. The slopes are reciprocals of each other. Let's go back to the first page to show you that. If you look at their slopes, this is 2. Inverses have reciprocals are their slopes. So if one is 2, the other one's 1/2. Same thing with this down here. If the slope is 3 for this one, the slope of its inverse needs to be the reciprocal of that.